All right, welcome back to part 2. This is on elimination. So the way we use elimination is you're going to do elimination multiple times to get down to a system with 2 variables, and then you're going to eventually solve your system, similar to like what we did with substitution. So what you need to do first is make a plan on which term to eliminate. So look at what maybe already cancels, what you could get easily to cancel, and go from there. So again, I'm going to number my equations so that we're all talking about the same things at the same time. And on example 3, I can see I've got y and minus y. So if I combine equations 1 and 2, my y's will cancel without me having to do any manipulation. So I'm going to do that first. And when I combine those together, I get 2x, the y's cancel, plus 3z equals 5. I don't have to do any more combining from there, and I'm going to go ahead and call this equation A. Now I can do the same thing, but with equations 1 and 3 instead, and my y's also will cancel. So x plus y plus z equals 4, and x minus y plus 3z equals negative 4. Combining those together, I get 2x, that cancels, 4z equals 0. And I'm going to call this equation B. Now, whichever variable you choose to eliminate, you need to make sure you eliminate the same one both times, because what you want is now 2 equations that have the same 2 variables. If you were to go through and cancel x the next time around, that would not be helpful, because now you have equations with y and z instead. So now I'm looking between A and B. I've got a 2x and a 2x. If I could manipulate one of them by, say, multiplying by -1, then I could get my x's to cancel. And in doing so, I will find that z is equal to -5. And just double checking, I did not make any errors with my negatives. We're good to go. Z is -5, so now I can find x by plugging back into either equation A or equation B. They're both kind of similar as far as the number of coefficients and how large they are, so I'll just go back to equation A for simplicity. So plugging in -5 for z here, 2x minus 15 equals 5, so I can add that 15 to both sides, and I get that 2x equals 20, which means x is 10. And now the last thing I need to solve for is y, and I can do that by plugging into any of my first 3 equations, because those are the ones that have y in it. Again, looking here, they're all pretty similar as far as difficulty, but equation 1 has no coefficients, so I'm going to go with that one. X is 10, plus y is what I want to solve for, plus we now know that z is -5, and that needs to add to -4. Well, 10 minus 5 is 5. When I subtract 5 from 4, I get -1. So my ordered triple in order is going to be 10 for x, -1 for y, and -5 for z. Okay, that one took a lot less time than substitution. So let's look at another example, example 4, and then I will show you a super easy peasy shortcut that'll save you a lot of time down the road. Again, I'm going to number my equations 1, 2, and 3, and looking ahead here at what I can cancel, I've got -5z and +5z. So if I combine equations 1 and 2, I can eliminate my z term without having to do any manipulation. 10x minus 9x is x, -2y plus y is -y. That cancels, and I miswrote, that should have been a 10. 0 plus 10 is 10. So here is our equation A. Now I can do the same thing with equation 1 and equation 3. Again, I need to eliminate z the second time around. So 10x minus 2y minus 5z equals 0. And then -9x plus y. Oops, I did the wrong equation on the first time around. I actually wrote down equation 3, probably because I was looking in the wrong place. -9x plus y plus 5z equals, and that would be -10. So x minus y equals -10. This is still going to be our helpful equation, but to get equation B, I need to actually use equation 2 this time. So 8x plus 3y plus 5z equals positive 10. 10x plus 8x is 18x. Negative 2y plus y is y. My z's cancel, and I get 10. Here's equation B. And again, looking at equation A and equation B, my y's will cancel without me having to do hardly any work. So x minus y equals negative 10 is what I'm going to combine. 18x plus x is 19x. That cancels. 10 minus 10 also cancels to 0. So if 19x is 0 and I divide both sides by 19, I get that x is 0. So I can plug that back in to solve for y in either equation. I'm going to go back to A. So 0 minus y equals negative 10. Well, that means that if negative y is negative 10, dividing both of those by negative 1 will show me that y is positive 10. And now that I know x and I know y, I need to plug back into one of my first equations to solve for z. Now, all of these are pretty much the same difficulty. You're going to have a lot of multipliers. I'm going to go with equation 3 because there's no multiplier on y, and I'm going to hope that that makes my life just a little bit easier. So negative 9 times x, well, we know x is 0, plus y, we know y is 10, plus 5z equals negative 10. So if I multiply this out here, this is 0, and then subtracting the 10 on both sides, I get that 5z equals negative 20. Dividing both of those by 5, I get that z is negative 4. So our final answer, as our ordered triple, is going to be 0 for x, 10 for y, negative 4 for z. Okay. We are going to move on to the last part, which will fit in this video, and that is matrices. I'll backtrack to special cases in a moment, but you should already be familiar with those to a degree, matrices. So what you need to do is go to Canvas, where you should already be, and click on the link for the Desmos matrix calculator. I will show you where that is now. So in Canvas, which you should already have access today to find this video, when you go to the module for this week, so that's the PDF copy of the notes, the videos you're currently watching. This is the matrix calculator that you're going to use. And it can embed right into Canvas for you, or you can just open it in a new tab if you'd like. But you could do desmos.com/matrix and it will pull it up for you. So before we get into what you're entering there, first we need to show you how to write a matrix. So a matrix, first you need all of your equations in standard form. And then we are just going to pull the coefficients and let the calculator do the hard work for us from there. Now, standard form means ax plus by plus cz equals d. All of your variables are on one side and your constant is on the other. And then we need to make sure our x is always first, y is second, and z is third so that our matrix solves correctly. So looking in the first equation, I need to fix this by moving 2x over and z over. In doing that, I'm going to end up with negative 2x plus y plus z equals 5. On my second equation, the only thing that needs to move is the y, so I will get x plus y plus z equals 7. And then on the third one, all I need to move over is the z, but I want to put x in the front. So negative x plus 2y minus z equals 1. Now that I have my equations all in standard form, I can write my matrix. I'm sorry, I just went through the hole in my paper. And so your matrix is going to go across each row, and you're just going to write down the coefficients. So I've got negative 2. Remember, when there's nothing in front, we assume the coefficient is 1. So 1, 1, and then 5 is our constant. Then I'm going to do the same thing for row 2. Those are all 1s. And then 7. And then the last one, negative 1. 2, negative 1, 1. So that is my matrix, and that is the values that I'm going to put in to my matrix calculator. So we're going to do a new matrix. We need 3 rows and 4 columns. So you are just going to enter those values that we just discussed. So negative 2, 1, 1, 5. Then I had 1, 1, 1, 7. Then I had negative 1, 2, negative 1, and 1. So this is all good to go now, and what I want my matrix calculator to do is this RREF. This is reduced row echelon, which is the mathematics. If you were to actually go to school a while back, you would have had to do this by hand with your matrices, but the calculator does it for you as a shortcut. And we put all this in matrix A. So we want it to do reduced row echelon of A, and what it shows us now is, because the 1 is in the x place, this is my value for x, which I realize is an ugly decimal, but that's just 2/3. The next one where the y is 2 2/3, and the last one where the z is, that is 3 2/3. So my solution here is 2/3, 3 2/3, 5 2/3. And you did not have to do any of that by hand. All right, we are going to do one more. Again, we need to get everything in the same form, everything on the same side. So with this x here, I need to move x and I need to move y. So when I subtract x from x, it's going to cancel to 0. So all I'm going to have is negative y equals negative 3. On the next one, I move the z over and I get 2x minus y minus z equals 0 because there was nothing left over here. Then x, I need to move over the y. Then I have 2z equals 10. And now I'm ready to set up my matrices. So in the first equation, I only have a y term. So what that means is where x and z go, I'm going to put zeros. And then my coefficient on y is negative 1. My constant is negative 3. On the middle row, I have 2, negative 1, 0, 1, 1, 2, 10. Going back to my matrix calculator, I'm going to clear all of this, and I'm going to make a new matrix again. I want 3 rows and 4 columns. So I've got 0, negative 1, 0, negative 3, then 2, negative 1, negative 1, 0, and then in my last row I have 1, 1, 2, and 10. So that is all good to go. Reduced row echelon for A, and there are my answers. Not pretty, but I did not have to figure them out for myself. 2.6, 3, and 2.2. So going back to my paper, I've got my ordered triple, and there are my 3 answers. Okay. With a little bit of time I have left, we're going to talk about special cases really quick. So you remember how this goes from the 2 variable systems? It's the same way. If you start canceling things out and you get a true statement, you have infinitely many solutions. If you start canceling things out and you get a false statement, it's no solution. So if I were to do substitution or elimination here, looking on, I think I'm going to go ahead and do substitution, and I'm going to get x by itself. So here, if x equals negative z minus 2, and then here y equals negative 2z minus 6 divided by 4, that's me getting y alone. What I have now are an x and a y that are in terms of z, and I can plug that into equation 2. So 2 times negative z minus 2 minus 6 times negative 2z minus 6 over 4 minus z equals 19. As I go through and distribute this, I get negative 2z. That will be minus 4, not plus 4. Then distributing the 6 on top and then dividing by 4 gives me 3z plus 9. And then I still have that minus z over here. So as I'm going through, I have negative 2z, negative z, plus 3z. That's all going to cancel. And then I have negative 4 plus 9, which gives me 5 equals 19. That is a false statement, therefore I have no solution. If I had ended up with 0 equals 0 or another true statement, we would have had infinitely many solutions. Okay, so that wraps up our notes on 3 variable systems. Matrices are a great shortcut and a great way to check your answer. However, you will need to be able to solve at least 2 by hand on a quiz, and then once it comes to the test, you can use your matrix. But on the quiz next time, you will need to do 1 by hand with substitution, 1 by hand with elimination, and then you get to use a matrices for the last one. So, miss y'all, see you when I get back.